2022 class. Here we are. The junior exams have been written, it's done. And the first thing that you need to do after the examination, of course, you have to go through the question paper and do the revision, do the corrections, and so that you know your strengths and your weaknesses. So it is not good to ignore the paper, whether it was difficult or it was simple. You have to start correcting your mistakes if you are to do well in the trial exams and at the end of the year. So here I'm bringing the voice behind the memo so that at least you have a voice that you listen to rather than reading the memo that is silent, which may not explain some of the steps. Okay, so you can get your paper that you wrote from your school if you don't have a soft copy of it. But we'll start with question number 1. Right, question number 1, we are given an equation. We are asked to solve the equations. The first one is minus into 1 minus x into x plus 2 is equal to 0. Now if you check this equation, the factorization has been done. On the right side it's 0, so half the work has been done. All what the examiner wants to check is how do you deal with this negative. Alright, the very easy way to get rid of that negative is to multiply both sides by negative. So if you multiply this side, multiply both sides by negative 1. So multiplying this side by negative 1, you remain with 1 minus x into x plus 2 is equal to 0. On the right side, anything multiplied by 0 is 0. So once you get here, now you know that it's either 1 minus x is equal to 0 or x plus 2 is equal to 0. That will give us, transposing negative x, it will be x is equal to 1 or x is equal to negative 2. So it's not necessary to expand because of the negative. All you needed to check was, how do I get rid of that negative? Alright, the next question is 2x squared is equal to negative 5x plus 4. Alright, the second question, you can see that it's quadratic and you need to rearrange first. So that will be 2x squared plus 5x minus 4 is equal to 0. Be very careful when you rearrange, because you can make a mistake there and then you lose some of the marks. Alright, then you must know that it's pointless to try to factorize this when they've said correct to 2 decimal places. The examiner wants to see if you are able to use the other 2 methods of solving quadratic equations, despite factorization, that is the quadratic formula, or completing the square. Alright, but then most learners, they resort to the quadratic formula. So you are having your A is 2, B is 5, and then C is negative 4. Quadratic formula says x is equal to minus b plus or minus square root of b squared minus 4ac over 2a. Then you do your substitution. I'll use this part on the board. So we are saying x is equal to minus b, that is negative 5, plus or minus square root of b squared 5 squared minus 4a is 2, c is negative 4, all over 2 by 2. That will be negative 5 plus or minus Simplify what is under the square root. If you simplify that, it will give square root of 57 over 4. And then the answers to two decimal places will be negative 3,14 or 0,64. Now, some learners, because they put this in the calculator, and then from here they go straight to the answers. If the examiner intends to give you a mark for simplifying, then you forfeit this mark. So let's just make it a habit that when you are solving, after a substitution, simplify, and then you give your answers so that you guarantee yourself no loss of marks there. All right, let's move on to 1.1.3. That is an inequality, and from the analysis that I have done in the past and even now, it is still a problem for learners to solve inequalities. We are having negative x squared minus x plus 6 is greater or equal to 0. We need the coefficient of x squared to be positive for us to be comfortable in our workings. So we have to multiply throughout, by negative 1. So we'll have x squared plus x minus 6. Now, when you multiply an inequality by a negative or divide by a negative, the inequality changes. So this tends to be less or equal to 0. And then from there, you can now do your factorization. That is x plus 3 into x minus 2 is less or equal to 0. Then the next thing, we need the critical values. That is like you're solving an equation. Your x will be equal to negative 3 or x will be equal to positive 2. Then from the critical values method, it's very important. Follow the steps if you want to pass. The method, some they understand the graphical method, some they understand the number line. Let's say you choose the graphical method. Your graph will cut the x-axis at negative 3 and 2. And checking here, the coefficient of x squared is positive. That means your graph will be concave up. There is part of the graph that is below the x-axis, there is part of the graph that is above the x-axis. So what we are saying here is that the values of y, which are represented by the quadratic equation, by the quadratic expression, x squared plus x minus 6, they must be less or equal to 0. So if they are less or equal to 0, remember that the values of y are positive above the x-axis and negative below the x-axis. So the part of the graph that is below the x-axis is what we must describe in terms of x, because we can see that the values of y, they are negative because the graph is below the x-axis. Below the x-axis, y is negative. So how do we describe this part of the graph? It is a closed inequality. That means we have a minimum and a maximum. So we are saying our x is greater or equal to -3, but less or equal to 2. That comes as our solution. If you decide to use, or you are comfortable with the number line, you have your number line -3 and then 2 there. So if you take a value that is less than -3, let's say you take -4, you put -4, you get -1, you put -4, you get -6. The product is +6. That means all values that are on the left of 3, they will give you a positive. And how do you describe values that are less than -3? X is less or equal to -3, following the inequality. And then in between here, it's x is greater or equal to -3 but less or equal to 2. And then this is x is greater or equal to 2. And what you should have noticed that if this extreme is positive, the middle one will be negative, and the other extreme will be positive. The extremes, they go hand in hand. So if this is a solution, this will be also a solution. This one runs alone. So we need where the product is less than 0, which is negative. So we take this as our solution if you decide to use the number line method. All right, moving on to 1.4. 1.4, it's a said equation. Square root of x plus 2 is equal to x. Of course, we have to separate the root so that we can square both sides to remove it. So the way it is fine. All what we need is to square both sides. If we square the left side, we will remain with x plus 2 is equal to x squared. And then this is a quadratic, we need to rearrange. Let's take everything to the right since the coefficient of x squared is positive. So we're having 0 is equal to x squared minus x minus 2. Now, factorizing this, that will be 0 is equal to x minus 2 into x plus 1. And then, therefore, x will be equal to 2, or x will be equal to -1. Now, before you even say you are done, remember they say the equations, they go with some principles. The principle that we need to check here is that the square root of a number, let's just use a, this should never be equal to negative number. So we need to check by substituting these values into our equation and see what happens on the left side and what happens on the right hand side. And is this fulfilled? So if x is 2, the left hand side will be square root of 2 plus 2, which is square root of 4, which will be 2. The right hand side will be x is 2, so it will be equal to 2. That means, therefore, left hand side is equal to right hand side. So this is a solution. Let's check with -1. Left hand side will be square root of -1 plus 2, which is square root of 1, that will give us 1. Let's check the right hand side, will be negative 1. So in this case, the principle of sets is not satisfied. So our x cannot be equal to negative 1. Okay? Let's move on to 1.2. 1.2, we are given 9 to the power x plus 2 times 27 to the power y plus 1 is equal to 3 to the power 1 minus x, like that. So we are asked to show that y is equal to negative x minus 2. Now, this is purely exponential equation which we are supposed to reduce to this. So the important thing is that we need to establish the same base first. Now, if we look at 927, a good mathematician will definitely see that there is a relationship on the basis there. So this will be 3 to the power 2 raised to the power x plus 2 times 27. 27, we write it as 3 to the power 3. And this is now raised to the power y plus 1, which will be equal to 3 to the exponent 1 minus x. Now, we can apply a law here, that will be 3. Then we multiply the exponents, that will be 2x plus 4 by 3 to the power 3y plus 3 is equal to 3 to the power 1 minus x. Now, this is multiplication. That means that we add the exponents. So we maintain the base and then we add the exponents. Since it's addition, you may not put in brackets, is equal to 3 to the power 1 minus x. The bases are the same, that means the exponents should also be the same. So we are saying therefore 2x plus 3y plus 7 is equal to 1 minus x. Then let's take the x to this side, it becomes plus, that will be 3x plus 3y. The 1 will be a negative 1 plus 6 is equal to 0. And then we can see that 3 is a common factor, so we can reduce this linear equation by dividing by 3. Dividing by 3 throughout. That will be x plus y plus 2 is equal to 0. And making y the subject, therefore, y is equal to negative x minus 2, which is what the question wanted us to show on 1.2.1. And then moving on to 1.2.2, hence solve for x and y simultaneously. Now, when you are asked to solve, don't go back to the given equation which they've asked you to simplify. It means this equation simplified is this one. So the equations that you are having is now x squared plus y squared plus xy is equal to 7, and y is equal to negative x minus 2. That's equation 1, equation 2. Now for this, it becomes simple because y is already the subject. So you are simply saying substitute equation 2 into 1. Where there is y, we'll put minus x minus 2. So we have x squared plus minus x minus 2 squared plus x into minus x minus 2 is equal to 7. Just make sure that you do your substitution correctly, because you are going to take time in solving this. So if you make a mistake, you realize when the answers are not coming well. Now expanding is x squared plus, expanding this, it will give us x squared plus 4x plus 4. And then removing brackets, it will be negative x squared minus 2x. Then we can bring even the 7 this side is equal to 7. So this will be x squared plus x squared plus 4x plus 4 minus x squared minus 2x minus 7 is equal to 0. Like terms, x squared plus x squared, 2x squared minus x squared, that will give us x squared. 4x minus 2x, that will give us positive 2x. And then 4 minus 7, that will give us negative 3, which will be equal to 0. And usually here factorization will do very well. And there are also other calculators that can solve. It will make your work easy. So the factorization, it is x plus 3 into x minus 1 is equal to 0. That is x is equal to negative 3 or x is equal to positive 1. And then this also tells you that you are not far from the correct answer. But if you start to come up with decimals, you start to require a quadratic formula. It's an indication. The examiner wants to test you if you can solve these equations simultaneously by substitution. Alright, then now we need the values of y. So when x is negative 3, y will be negative by negative 3 minus 2. And that will give us positive 2 minus 2, positive 3 minus 2, that will be 1. And then y will be negative 1 minus 2, that will be negative 3 when x is 1. And then we can say we are done with the solving of this equation. Now moving on to 1.3. 1.3, you are asked to prove that the roots are real. Now, this is a question which falls under nature of roots. And if the question is saying the roots for which the roots are real, if roots are to be real, it means delta or discriminant is greater or equal to 0. So, what we are simply going to do is to check that this delta, is it really greater or equal to 0 for all values of x. So, let's rearrange. That is x squared plus px minus 1 is equal to 0. That's our quadratic, which means that our a is equal to 1, the coefficient of x squared. Our b is equal to p, the coefficient of x. And our c is equal to negative 1. So we are saying the discriminant will be equal to b squared minus 4ac, which will be p squared minus 4 by 1 by negative 1, which is p squared. Negative 4 by 1 by negative 1 gives us positive 4. And now if we check, p squared will never be negative. 4, adding 4, it will simply add on to a negative number. So we are saying therefore, roots will be real because p squared plus 4 will always be greater or equal to 0. That is how we answer this question, of which definitely this p squared plus 4, in actual sense, it will always be greater than 0. Because for any value of p, the minimum you can get is 4. So it was just a point of showing that the discriminant will always be greater than 0. Alright, then 1.4, which is the last question. You are given that x plus 1 over x is equal to 10. And x is greater than 0 because x cannot be equal to 0. This whole statement will be undefined. Determine without solving the equation the value of. Now, how do we get this x squared plus 1 over x squared from this? If you have tried a few problems in the past, you should have noticed that to get this, you need to square this. So if we square both sides, that is, we square. If we square this side, we get x squared plus 2 plus 1 over x squared is equal to 100. And then we take the 2 to the right side, or we subtract 2 from both sides. So we will remain with x squared plus 1 over x squared is equal to 100 minus 2, which will give us 98. That is that. So that's what you were supposed to do to get the 29 marks. I hope the voice behind will serve to explain some of the concepts that were a bit difficult for you. We'll meet when we do the second question.